So solving this triangle is actually pretty straightforward. I'm basically going to get b by itself and do the inverse sine formula. So if I do that, I'm going to go ahead and say sine of b happens to be equal to, um, this one's going to be the ratio of 20.4, which is nice, and 41.5, all of that times sine of 29.7 degrees. Plugging things into my calculator, I get a decimal approximation, which I'm going to write down over here, that sine of b equals this 0.24355 and so on. So sine of b equals 0.23455. So that's my decimal approximation, but I really want to know what this angle is. So I'm going to go ahead and take the inverse sine of both sides. And in doing so, I'm going to figure out that b is approximately equal to, on my calculator, I get that the angle b is about 14 point, I'm going to go ahead and say 10 degrees. I'll write that down. Just so my significant figures match with what I'm getting 14.1 degrees. And we kind of have a branching point here. Now that we figured out this angle of b, we can finish and try to solve out the rest of this triangle. So I'm going to go ahead and do that. I can figure out what c is pretty easily now that I know what a and b are. Also notice that b is a skinny angle. This will come back in just a minute when we try to find the second triangle. Anyways, so I go ahead and figure out what C is basically just going to be the same thing as 180 degrees minus my other known angles. B, plug some stuff in, and we end up getting that it's going to be about equal to, we get the missing angle for C is 131.2 degrees. And in the interest of saving time, I'm just going to go ahead and say that the law of sines, we will use law of sines again, and we want the law of sines to find out what is this missing side. I kind of can't show. I'll scroll up. What is this missing side of my triangle? That side C. And so I could just go ahead and choose whatever I want to fill this in as long as I have the C inside of it. So I'm going to put my unknown C right here over the angle I just found, which is sine of 131.2 degrees equals the other side, all the other A's, which is the A, sorry, so my side A is going to be 41.5 feet, and my angle for A is going to be sine of 29.7 degrees. I should note that I probably want to use more decimal places because every time I do this, every time I round, I introduce an error. And if I'm doing the homework, it's probably fairly particular that I need enough decimal places to minimize my error. And in the process of calculation, I don't want to round to my least significant figure right here. I want to round to a super significant figure over here so I don't introduce errors with each calculation. At least the errors that I introduce with each calculation are far below my significance error. And that's just a philosophy for doing math and calculations when you're doing rounding errors. Algebraically solving for values, and so algebraically I would have multiplied a sine of this crazy angle to both sides, and then I did all that in my calculator already, and I figured out the side length C for this crazy triangle is 57.97 feet, and I'm probably rounded up to 58.0 feet. So I've solved one of these triangle scenarios. I know all the angles and all the sides. As the title of this problem suggests, there is another triangle that will also solve the very same given information. And I will go ahead and solve that one next. I'll probably need to erase some of this board so I have room to work.